In this video, we will be learning about algorithm analysis and that too how it is related to data structures. So let's simplify this concept and try and understand why it is needed and how it will reflect into our programs or into the algorithms that we write. So first thing that is important while understanding algorithm analysis is why it is required. So it is required to understand the efficiency of the algorithms. And then we will be learning specifically about why the performance matters and what is the concept called complexity, how it relates to analysis. These are some of the important concepts that we will be discussing about in this video. Now, what is algorithm analysis? So, it measures how efficient an algorithm is. So, it calculates the running time, it calculates the usage of the memory, and it is important for the large data. Obviously, if we are doing or running a very small code, we may not be worrying much about the time and space that program will take. But whenever we have to deal with a larger program, a big software, we have to take care of how much time it takes to execute certain parts and how much memory it occupies. So these are the two main resources that we should always think about while analyzing our algorithms. So what are those two main resources? We can clearly see them in this particular slide. It is the time and space. So when we say about memory usage, memory is basically the space that your program or the variables or all the things that you are utilizing in your software will be denoted through a space, okay, also called as memory. So the two main resources that your analysis, algorithm analysis will be focusing on is running time and the space. Now, what is an algorithm? So we are talking so much about algorithm, its analysis, how it performance matters, and why we are focusing on time and space, all that stuff. But first, we should know what is algorithm. So in very basic language, it is just a step-by-step procedure, and those steps have to be sequential. They will be representing a pure logic to solve the given problem. Now, there are three things that are important while processing any algorithm. First, it has to take an input. Second, it will be processing that input. And third, it will produce an output. So this is basically a cycle that it follows. First, it will start with input, then there will be process, and then there will be output. It is again that I have to mention that input may not be mandatory every time. Like if I just need to print hello world, I may not need an input for my algorithm. But in most cases, wherever I am writing some larger programs, I will always need an input. So that way, these three things are the key parts of your algorithm: input, process, and output. Now, as I said that whenever we talk about algorithm analysis, the two main concepts that come along with it are its two resources, that is time and space. So the first thing we need to focus on is time complexity. Now, what is time complexity? So it measures how running time increases with input size. So if I am taking only one input from the user, how much time it will take to run that particular code? If I'm taking two inputs for the same program, how much time it will take? If I'm taking three input values for the same program, how much time it will take? And so on. So I need to see respective to my, with respect to the input that I've given, the size of the input or the number of input values, how the time is getting affected, the running time of my code. So that is very important because that way it will just denote the performance of my software, how it will behave when it will be actually launched. Okay. Now, to denote it theoretically, in theoretical terms, we have some notations. And to denote time complexity, we can use a notation called big O notation. Now, there are some examples given here, like O1, O of n, O n square, O log n. All these examples are basically based on some of the programs on which we will decide its notation. So we will be discussing these practical examples as well. so that you will get a better understanding of what all these notations are about and how to determine them. For now, we will see one example. We will discuss it here called linear search. Now, when we say linear search, it is about searching one value by comparing it with every value in the collection or in your data structure. So it checks elements one by one. That is why it is linear. And if the element is present at the end, all the elements are checked. Now, you can see that the time complexity for this is written as O of n. So why it is O in bracket n? What is n here? So n is basically the number of elements that are present in my data structure. If I am searching for the last value, if I will get the value at the last position, the number that I'll be reaching to will be at the length of my collection, and that can be denoted as O in bracket n. We will also see it in a more practical manner in the next video so that you will get better understanding of the same thing. This is the program, this is the logic that we will follow for linear search. So there is a for loop you can see, and it is going till the length of the array or the list. We are comparing each element from the list with the target, that is the value to be searched. If they are matching, we are returning the index of the value. If they are not matching, we are returning -1 at the end. So if we get the negative value at the end, it will mean that we have not got that particular number in entire collection or in the entire data structure. So if we are not getting the value, that means still we did all the comparisons till the end. So in such a case as well, the time complexity or the time we took will be represented as O in bracket n. Moving on to the second and important resource, which is space. And that is why that has to be also determined with the help of a concept called space complexity. So it measures memory used by an algorithm, that how much space it will occupy, okay, while running or during its execution. So how we can determine the space? So it is about extra variables, increase space usage. Whatever are the extra variables other than your input values will be showing the space usage. Efficient programs use less memory. So this is very important part, that if I want my program or my software to be efficient, I have to focus on usage of very less amount of memory. That will make my program more efficient. That's it. This was all about what is algorithm analysis, why it is important, and what is space and time complexity. So I hope this video helped you understand algorithm analysis. If you found it useful, like this video, share it with friends, and subscribe to my channel for more programming tutorials. Thank you so much. Bye-bye.